Hello and welcome everyone. My name is Kelly here with Esri and I'd like to welcome you to our webinar today. Today we're going to be discussing trusted authoritative information in uncertain times. And with that, I'll go ahead and turn it over to our first presenter today, Mark Seigan.
Thank you, Kelly, and welcome everyone. My name is Mark Seigan. I am the Director of National Mapping Solutions here at Esri. And I've been with Esri for 25 years, and I've been in mapping and GIS for over 35 years in various roles in geospatial production and mapping as a production manager, as a project manager, as a consultant, and in my role here at Esri. I'm joined by my colleague, Steve Snow. Steve?
Hi, Mark. As the slide says, my name's Steve Snow. I work as a National Government Industry Strategy Specialist focusing on national mapping, air, land, and sea, and imagery and remote sensing. I've worked with NOAA and also with the U.S. Army. But I'm centered in Redlands with Mark, and I look forward to showing you some examples.
All right, thank you, Steve. And we'll be hearing more from Steve later on. And what we're going to be covering today is looking at these, trusted information in uncertain times, and in the context of National Mapping and Geospatial Authorities. We're going to be looking at the state of play currently with those organizations, and then we're going to look at modernization. And that may not be, specifically new, but we're going to be talking about in the context of transforming your organization to be more responsive and relevant to your customers and key stakeholders, that transformation of your organization while you're modernizing. And then we'll show you how many of your colleagues in similar organizations are transforming themselves and their relationships with their customers in uncertain times, like the times we're living in right now. Our world is obviously changing right now. We're very challenged. And national mapping and geospatial authorities are usually asked to support the national government response in times of crisis, like this COVID-19 coronavirus and other epidemics, and especially in natural disasters and man-made disasters. Your base map data is crucial to understanding the environment and providing context and actionable information to decision makers, and to provide the trusted, authoritative information needed in these uncertain times. It's particularly important when critical features are covered by things like floodwaters or coastal surge, landslides, and fires that burn them beyond recognition. National mapping and geospatial organizations face many challenges today. We see expanding stakeholder and user expectations from across government, industry users, non-governmental organizations, all the way down to the individual citizens. There's an escalating demand for a broader range of information products, from maps and data to web services and analytics. There's a need for faster delivery of near real-time information, coming from a larger, expanding variety of sensors, all the way to the delivery of many types of information to many types of devices and apps. Increasingly, the demand is for better resolution and higher quality data. And all of this is while your staff are continuously trying to stay ahead of the technology curve so they can leverage the innovative ICT to better fulfill your organization's mission. While all of this is happening, many national mapping and geospatial authorities have had their budgets and their revenues cut by 25 to 50% in the last few years. This has resulted in fewer staff and overall resources to do this increasing work that's demanded of them. We are also seeing shrinking timelines from initial point of data collection to the final delivery of information that's required to meet the increasing expectations. And many of you are wrestling with how do you adapt to all of these challenges, and there often seems to be a reduced perception of relevance in parts of government and society. And we're going to address these today as we go through the webinar. It's important to note that that modern national mapping and geospatial authorities and their customers and their key stakeholders are looking for tangible outcomes. They're looking at how to enable themselves to do more with less. This includes increasing your responsiveness by speeding timely information to decision makers, increasing relevance by leveraging technology and expanding your capabilities for data analysis and information delivery. This can be done by leveraging faster computing, parallel processing, using things like artificial intelligence and neural networks. Some of these types of leveraging these technologies is helping us save time and money, the staff labor time, and reducing the environmental impact. By increasing our efficiency and expanding our capacity, it's enabling us to do more with less. And by automating our routine tasks, we're enabling our geospatial professionals to focus on higher value projects and outcomes, and enabling them to deliver much more information. And of course, improving accuracy and engagement with our user community. Many of the leading national mapping and geospatial authorities are collaborating through the United Nations Global Geospatial Information Management, or UNGGIM for short. They're working together and sharing best practices on things like the Integrated Geospatial Information Framework and providing countries guidance on the 9 strategic pathways to building their geospatial infrastructure. This is pretty significant. I've been involved since the very beginning of UNGGIM on the preparatory committees, and the UNGGIM is recognized in the UN. It was passed as the United Nations Economic and Social Council resolution in July of 2011. That was the first time that a committee of experts had been stood up in over 20 years. So this is recognized by the UN as a significant effort that's being done by these national mapping and geospatial authorities. And I want to point out there's a number of really good working groups going on, but one of them is the working group focused on the strategic framework on geospatial information and services for disasters. And it was adopted by the UNGGIM Committee of Experts in August of 2017. It was subsequently adopted by the United Nations Economic and Social Council in July of 2018. And it's based on the widely recognized Sendai framework for disaster risk reduction in the 2015-2030 agenda. And it was endorsed by the UN General Assembly in June of 2015. So that's a significant piece of work. So let's look at just some of the key points there. There's basically 5 key objectives in this, and it's better governance and policies, because nations have a responsibility to protect their citizens from social, economic, and environmental impacts of disasters. And the policies need to reflect that responsiveness of government. And that leads to awareness raising across government and capacity building within our organizations. And these are needed by governments to properly manage risks and the impacts of disasters. And this can only be done if nations and other stakeholders are fully aware of their geospatial data and information holdings, and bringing the necessary changes to make that geospatial information available and accessible. So that leads us to data management. The geospatial information is an important aspect of disaster risk management, ensuring that decision makers have accurate, common operating picture data. Now, it's generally accepted that during disaster situations, data sharing and mechanisms in support of decision making are generally not in place. So there's a gap between the geospatial information that's needed and getting it to the decision makers. And so we need to endeavor to have a common infrastructure and services for geoinformation to properly respond. And that leads to the requirement for the need for a resource mobilization so that we can close that gap between the current state of geospatial information and informing the decision makers. So I'm going to switch gears here a little bit and talk a bit. Many of you may have heard Jack Dangerman, the president of Esri, talk about our world as a living organism, much like humans. And Jack describes GIS as an integral part of a central nervous system. And I would dare to add that it's connected to decision makers, that central nervous system. And national mapping and geospatial authorities play a critical role as part of this nervous system. You have many sensors that help us recognize, map, and provide trusted and actionable information about our changing environment for decision making. And ArcGIS plays a big part in supporting national geospatial authorities, fulfilling their roles and mission. ArcGIS is a comprehensive geospatial platform. It is services-based, distributed, open, and extendable. And it's really facilitating the collaboration among individuals, teams, and organizations. Our world is experiencing many new innovations in areas like data measurement, computing, and the sciences. ArcGIS is enabling us to leverage and harness many of these areas and technologies. ArcGIS also provides 3 fundamental systems for your organization. Many of you actually are the authoritative record registration for your countries. And ArcGIS provides that system of record that you can manage all of that information. And it also has, because it's not just mapping, it's geospatial, it's GIS, it allows you to take that authoritative data that you collect and compile and manage and steward and do the analytics, do the geoprocessing on that data and derive information and knowledge and insights. So there's really a system of insights that's available. And increasingly what we're seeing with web services and is a system of engagement. We're able to abstract that information from our trusted data out into maps and apps and devices and really make it available to anyone. ArcGIS also enables us to collect and manage many different types of information: vector, raster, imagery data, LiDAR, big data, and so on, as you can see. And it abstracts that data into a common language that people understand of maps and scenes and layers. It's really a unifying tool for bringing all of this disparate data that you collect together and then creating a trusted source of information that's meaningful information. So for geospatial authorities, it's enabling us to build a trusted, authoritative body of knowledge, really a single point of truth for our nations. And all that information needs to be shared out, as I mentioned, in the system of engagement. And we're seeing not only sharing, but far more than that. We can be used to engage communities around common issues and causes and initiatives. ArcGIS enables these communities to collaborate around initiatives using geospatial data, maps, and apps. And this is evolving data sharing into collaboration with communities, using geospatial information to inform decision makers. Now, as we talk about national mapping and geospatial authorities modernizing, using GIS, we really, as geospatial organizations, we have to ask ourselves some hard questions. Like, are we consistently building the capacity of our workforce to meet our mission? Are our processes able to keep pace with the increasing requirements and quick turnaround times our customers demand? Are we able to consistently maintain and deliver the most current map data and make it available 24/7, 365? And are we fully leveraging the ICT technology like GIS to enable our people and processes and information to be the very best that they can be? Using GIS, we see national mapping and geospatial authorities better able to become what they want to be, what their governments need them to be. Geospatial authorities are contributing to issues of national importance and relevance, and this is enabling them to get more sorely needed resources. This is making them more responsive and engaging across government, industries, society, and even to the individual citizens. It's moving us from creating static map data to trusted, authoritative information custodians who are maintaining dynamic information and sharing it in near real time and collaborating. And this is enabling us to be more efficient as we equip and align our people and processes and our customer requirements using modern technology like ArcGIS. ArcGIS supports the core mission of national mapping and geospatial authorities to collect, analyze, produce, and share information. All of this is using your organization's corporate knowledge, models, and business rules. You don't have to change them. We just encapsulate them. It's all managed inside of a modern GIS. One of the innovative processes to modernize our organizations is automation and the automated data-driven production of our information products. ArcGIS provides the ability to automate your organization's production by applying your map rules to your current authoritative information and data, then running geoprocessing tools through Python scripts in order to automate and generate the production of maps, geospatial data, and other information products. So I'm going to take a stop here, and we want to get some feedback from you. We'd like to hear from each of you, and we're going to pull up a poll here. The question is, what are the biggest challenges your organization is facing today? Maybe it's their biggest issues are responsiveness to expanding customer requirements, or maybe it's mind share and importance of your organization to decision makers, or perhaps it's sustainable resources for your organization, and it might be ability to fully leverage technology. And we'll see what the results are. Right now, it looks like what's leading the pack here is the ability to fully leverage technology. And then we see kind of an even distribution of the other three. And it looks like the ability to fully leverage technology is one of the biggest challenges. So I think we're going through that, and we'll continue to show you that today. And we're going to show you what some of your colleagues are doing with the technology today. And then the second one looks like sustainable resources for your organization. So now let's come back to disasters and national response. A significant challenge for any nation is preparing for and responding to disasters. This requires authoritative geospatial information from national geospatial data providers. And as we saw earlier in the UNGGIM strategic framework on geospatial information and services for disasters, and the Sendai framework for disaster risk reduction from the UN, the following are examples of some of the organizations that are doing this. So first, I'd like to talk about the Ordnance Survey, Great Britain. They've been a long-time user with Esri. They have a very robust set of authoritative geospatial data for the United Kingdom. And they've identified over 200 use cases for its data across the government and society. And it includes emergency response. In fact, the Ordnance Survey data has been critical in the UK government response to the extreme flooding events that we've seen occurring in the UK over the last few years. This is underscored by the UK spatial strategy that was just released a little over a week ago by the UK Geospatial Commission, of which Ordnance Survey is one of the 6 principal partners. And if you go to that, and this will be in the webinar, you'll see the links. If you go to that UK geospatial strategy, you'll see it includes opportunities, which is emergency response, harnessing data to save lives. Another example, and it's a little bit of a story here, is let's go to the other side of the world, to Queensland. It's located in Eastern Australia. And Queensland's Department of Natural Resources, Mines and Energy have been an Esri user for many years. In fact, I remember working with, and their geospatial and mapping authority is inside of this organization. I remember working with them a number of years ago, back in 2010. They had the wettest December on record, and they had rainfall that covered this state with an average of 8 inches of rain in 1 month. And the resulting series of floods that came out of that forced the evacuations of thousands of people in towns, and it destroyed much of Queensland's economy and infrastructure, including a lot of the rail lines and the roads. And only 3 weeks after this flooding, on February 3rd, 2011, a Category 5 cyclone made landfall in northern Queensland. And while the floodwaters were destroying the floors and foundations of the buildings from the rains, this hurricane, Yasi, ripped off roofs and toppled trees. Unfortunately, more than 30 people lost their lives. And the economic toll from the devastation was around $6.8 billion. It was devastating. But in that time, they were using the ArcGIS platform, and they provided us, the Geospatial Authority provided a single source of data for all the responders, including the Australian Defence Force and the Emergency Management of Queensland and the Insurance Council of Australia and many others. And fortunately, they had put their information up in the cloud after the devastating floods, because they were concerned their infrastructure was going to be overtaken. And it was fortunate that they had put it into the cloud, because indeed government, when the Category 5 cyclone came through Yasi, it did do major destruction, but there was no disruption in the delivery of geospatial information during this disaster, because they had put their information in the cloud in another location. So now let's fast forward to the end of last year in 2019. And many will remember the devastating bushfires that ravaged parts of Australia. And then immediately the country had to prepare for floods and severe rainfall in 2020. But though there was flood and fire and cyclones, and they're very different disasters, the recovery approach actually that was required is very similar. They had to map out the floodplains. They had the historic floodplains, and they're mapping out the extent of the floods and gathering flood information and assessing flood and cyclone imagery where available to get real-time information. And because of their experience in 2011 with the flood and cyclone, they created a damage assessment and reconstruction monitoring system. And that system has been used in over 14 natural disasters since then, and in over 45,000 individual disaster assessments. And the Queensland Reconstruction Authority conducts street by street and house by house inspections during floods or bushfires and cyclone affected communities. And they identify the level of damage, the damage patterns, and where the greatest needs exist. And they help accelerate the insurance payments out to users. So that's an interesting story from Australia. Let's move to the United States, and we'll take an example of a disaster response to hurricanes here in the U.S. Particularly in 2018, we were hit by a hard season. There was Hurricane Harvey, Hurricane Irma, and Maria. And in 2019, there was Hurricane Matthew, all major hurricanes. And we can see from this picture that decision makers at the highest levels can benefit from GIS. Let's take Hurricane Harvey, for example. And I'm going to use some slides from my colleague at USGS. Carrie Cron was the director of the National Geospatial Program's Technology Operations Center. And in her words here, she was describing Hurricane Harvey as a Category 4 hurricane. There was over $125 billion in estimated damage. They had over 60 inches of rainfall in a short period of time. And unfortunately, they had 68 deaths, and actually more that were indirectly related. And there was an immediate need for authoritative geospatial information. And the USGS had created they had used the Esri product on demand, and they had created what they called their dynamic mapping program. And they were able to produce the 1 to 24,000 scale maps, not only for Harvey, but also later for Irma and Maria. And they ended up producing 9,000 of these individual 1 to 25,000 scale maps for all of the Southwest United States and Puerto Rico. And they were able to do that from authoritative, current information using this print-on-demand capability and generating these maps that were needed in hard copy through the Defense Logistics Organization that got them printed and delivered to the first responders. And they used that for urban search and rescue and detailed street level planning. However, in the process, they realized they also needed some smaller scale maps, specifically 1 to 25,000 scale. And so the call came back from first responders that they needed these 1 to 250,000 scale maps, to do strategic and operational planning to support the National Guard and emergency management organizations for situational awareness and planning. And so they quickly went to the product on demand or the print on demand system, the product on demand and dynamic mapping, and they went and configured in 4 days. They reconfigured the system to create these new maps. So literally from the time of request to the organization to the Geospatial Information Response Team, which is the U.S. Department of Interior's response team to disasters, where this program was used, from the time of that request to the delivery of those hard copy maps to the first responders was done in 8 days. And so the kind of the return on investment to USGS is it demonstrated the ability to quickly configure the product on demand system, the dynamic mapping to produce this new scale of map. It reduced the resources that was needed. It would have taken significantly more resources to have done this in the past. And it increased their awareness of what customer needs were. And the customer needs were, and the value to first responders was the ability to use these maps to do pre-storm evacuations, to do search and rescue missions, recovery operations, and many other tasks required. And they were able to do this with maps, even when the power was down or the cell services had been disrupted. They were able to use these 9,000 maps to respond. And they said it was key to have this authoritative information available in the right place at the right time, and it was absolutely critical to effective operations in response to the storm. So I mentioned the USGS Geospatial Information Response Team, and they have put up what they call their Event Support Map, or ESM, for a number of different disasters. And my colleague Steve Snow is going to tell you a little bit about that and tell you a story and demonstrate some of this capability. Steve?
Thanks, Mark. Okay, so I wanted to start out showing the USGS's Event Support Map Open Data Access page. This is publicly accessible. The USGS has two areas on this website. One for direct access for departmental teams, the storm team, the flood team, and other hazards, but they do have a public access section. So the Geospatial Response Team produces both event support maps and what's new is an MRCTI viewer, and I'll be showing that in just a little bit. So again, each of these can be found on the public access portion of the Open Data Access page, so you can check this out yourself. So the Event Support Maps, or ESM, is an ArcGIS Online application that provides easy access and use of spatial data. It's based on Esri's Story Map application that can have embedded websites, maps, dashboards, and applications, such as real-time. The goal of the USGS support maps is to make the data usable to the public. Event support maps provide easy access to spatial information and relevant applications to the event. Each event support map is designed for a specific event, such as a hurricane or tornado or flooding. So the main purpose of this is to assist with additional imagery, water level, agency information, topo maps, and 3D elevation data from the 3DEP program. So in this slide, you see NOAA data in the ESM of Cedar Island before Hurricane Dorian. So in the pre-event imagery, you can compare damage assessments from the storm. So in this case on Cedar Island, which is one of the coastal barrier islands, you can see a breach which from the hurricane can cause inundation on local communities. Additionally, events such as tornadoes, you can compare the pre-event imagery and post-event imagery all in the same browser or application. So on the left here, you can see the pre-event Smith Station, Alabama imagery. And on the right, you can see the resulting damage assessed from a tornado post-event. So here you can see all the vegetation that's been stripped away from the landscape, all the houses and infrastructure that's been damaged, and be able to respond that as soon as possible. So here we're going to start covering the MRCTI viewer. This is a new viewer. The MRCTI viewer is meant to provide imagery and information that supports the Mayors of the Mississippi River Cities and Towns Initiative, or MRCTI. The viewer helps with coordination, communication, and access of geospatial resources during disaster events. The viewer is built on the Government Geo platform and was used this year for local communities during the Mississippi River flooding. Some situational awareness information that's shared are stream gauge levels, weather forecast, imagery access, and imagery comparison tools, as well as access to other agency data such as NOAA, FEMA, NASA, and others. So in this slide, I'm going to show you one of the features of the MRCTI viewer, which is the stream gauge flood stage. The MRCTI Disaster Prediction and Assessment Portal provides many types of information. Here we have the stream gauge flood stages, and with that you're able to look at specific cities, you're able to look at specific gauges by number, or you can select by different stages of flooding, such as above major flood stages, above moderate flood stages, above standard flood stage, and above action stages. This also allows you to drill down to the individual station and view the information so that it's available to local communities. Okay, so the next section that I want to cover on the MRCTI viewer is the earthquake dashboard. This is a new feature. The earthquake dashboard on the prediction and assessment portal lets you view recent events such as earthquakes. It allows you to zoom to individual cities. It applies imagery in the area, maps within the area. It also allows you to view seismic events such as earthquakes within the last 7 days, or the ability to filter to much broader events such as the last 30 days. What this does, it breaks down these activities as either red alerts, orange alerts, yellow alerts, or green alerts. And right now you see there's only about 14 different smaller incidents here, such as earthquakes. You also on the left-hand panel here have recent events, such as being able to look at a recent earthquake in Julian, California. It's only about 0.73. But you notice also that imagery is provided for the area so you can look to see if there's any impacts that these events have on the communities. The other ability that is readily available is being able to drill down to the individual events, such as each one of these blue dots has additional information, such as here in Oklahoma, we have a magnitude 1.12 earthquake at 7 miles deep. You can also go to the USGS's official website and be able to view interactive maps, regional information, derive additional attributes for seismic activity. Okay, the next section we're going to cover is the USGS map locator, which is based on the product on demand that Mark had spoke about earlier. So this section 10 on the Disaster Prediction and Assessment Portal covers the USGS map locator and download. What this allows you to do is search for local USGS maps. So here we're going to search for Germantown. And we'll go to Germantown, Tennessee. And what this allows you to do is download your maps on demand. It's pretty simple. All you have to do is click on the quadrangle of the area of interest right there, click download, and this will prompt you to download and save. So I'll go ahead and save. And we'll go ahead and open it up. And there's your Germantown quadrangle. A ready-made map of the area of interest. And you can do this multiple times as well. So thank you very much. Okay, Mark, I'll go ahead and hand this back over to you then. Mark, are you there?
Yep, sorry, I had my mute on. I apologize. So thanks, Steve. I appreciate that, and it's good to see what the USGS is doing in disasters with their product, using the use of the story maps and the product on demand and the event support map that's based on story maps through this MRCTI, the Mississippi River. And it's interesting to note that there's hundreds of billions of dollars in commerce that's goes up and down the Mississippi River, and so this event support map that supports the communities around the Mississippi River has a huge economic impact for them and for the country at large. So just moving on to some other things, obviously many of us are dealing with the COVID-19 coronavirus. It's affecting all of us, but many geospatial authorities are responding to this disaster. And Esri has stood up a number of resources in their the COVID-19 hub, as well as other resources that's being used by geospatial authorities around the world. And you can see in the middle there's the index of global applications. You can actually go and see all of the hubs around the world that are using this technology. Many of you are probably familiar with the map that you've seen from Johns Hopkins, and the data that they're creating is being picked up and used by dashboards around the world. What we're seeing from national geospatial authorities is really mapping the extent of the disease. And if you go to the Esri COVID-19 response site, you'll see there's actually 5 easy steps on how to map the extent of the disease and track it. Many of you are also providing, very quickly providing the key geographic information and features that are needed to support things like compiling points of interest like hospitals and cemeteries. You're ensuring the data is current and deconflicting different information from different sources, and then publishing it and making it available through things like the hub, the ArcGIS hub. And many of you are accurately mapping the extent of the disease, as I mentioned, and collecting data on locations where people congregate so that we can look at potential hotspots, and doing geographic analysis of the spread of the disease and identifying potential hotspot locations where it might go next. So one of the slowly unfolding disasters is sea level rise and the effect on critical infrastructure. And our colleagues at NOAA have recognized this and identified a tool. And you can see the blue areas around there are potential sea level rise. And if you look at on the right, we see the San Diego Convention Center where the Esri User Conference normally is held. This year it will be a virtual event, and the plenary is open and free to anyone, and the entire conference is open to anyone with licenses. And you'll see that the conference center where we normally hold this, even with a slight sea level rise, is going to be affected by sea level rise. And you can see the areas that are affected in red, the infrastructure and the essential services that are affected in red there. The tool actually, NOAA's identified where sea level rise is happening, and you can click on any of these arrows around the world and get measurements on how much the sea level is rising. We've got the example of La Jolla here near San Diego. And there's also a model that the Old Dominion University has done with the NOAA data, and they are looking at inundation. So if we look at this, it's widely recognized that sea level rise will probably be between 1 and 2 meters, or about 2 to 5 feet potentially. And in this model here, we see the inundation areas in the blue, covering things like piers. So if we extend that data and look at that, actually, if I go back, so the blue area is the piers that are covered by the very conservative model. The green areas are low-lying and inundated areas. If we extend that into the 2040 and we look at the intermediate model, we see the areas in red representing buildings and roadways at highest risk. They are below the high tide line. And we see some downtown buildings. All of the piers are covered now, and many of the major arteries and bridges are covered. The orange represents areas that are impacted by tidal flood events, and the yellow are impacted by moderate flooding events. And the same color schema you can use as we extend this from 2040 into 2060. We can see the downtown area, including the shopping mall area. And then as we move to the right, you can see Harbor Park, the baseball park, the Amtrak station, and many other areas along the waterfront affected by this. And as we go to 2080, even farther extreme events. So there's links here. You can go look at this tool and use it and take a look anywhere in the country. So I want to go to our last example here, and I want to talk about artificial intelligence and deep learning, machine learning, and really applying it to geospatial information, or what we call GeoAI. And what we are seeing, we're working with a number of national mapping and geospatial authorities in a community to identify priorities. And that community has identified change detection of areas and features, feature identification and extraction, and analysis and assessment. And the high value use cases they're looking at is change detection for roads and buildings and land cover, for road extraction, for national mapping and other census type organizations, looking at buildings and then the national land cover or agricultural census. There are many other examples. Here's you see here, including damage assessment. And I'll just show you very quickly one example here during the hurricanes in Florida. We see in blue the buildings that aren't affected, but red are the damaged features. And so if you can very quickly, using geospatial information and AI, identify the damaged features and the partially damaged features, and quickly do an assessment when in times of disaster, and be able to quickly respond. And so you can identify things like damaged structures, detect damaged roads. You can actually use it for optimal routing to direct your first responders. And all that can be brought together in an operational dashboard to help decision makers in making decisions to respond to these. We don't have a lot of time to go into this, but there's many different, we've done webinars on this that we can make available. And there's also projects and areas that you can get more information. I've given you just some examples here and a link to go to our GeoAI gallery of applications. So I'll leave you with one last example here, and that is the Department of Defense Joint Artificial Intelligence Center is applying this GeoAI that I was just showing you with AI innovations for global humanitarian assistance during disasters. Prototyping, the project we're working with them on is prototyping advancements in rapid damage assessments during disasters. And the ArcGIS platform is using the predictive power of location intelligence to provide this insight coming out of this GeoAI and deep learning. And ArcGIS really is a foundational platform for GeoAI to enable things, customers like the Jake, to quickly prototype models, deploy them, and build meaningful dashboards, maps, and apps in times of disaster. We've got another poll question here, and the question we have posed to you is, how are you using GIS in your organization's response to disasters? Maybe you're providing the base maps and the geospatial data to visualize disaster impacts. Maybe you're using GIS to do damage assessment after disasters and directing first responders. Or maybe you're doing even more and you're using GIS to analyze, predict, and mitigate future disasters, and that's great. Maybe you're not doing some of these things, or you are, and you're interested in automation that we talked about earlier, or GeoAI that I was just talking about to speed disaster response. Or maybe some of you just you're thinking about doing these things, but you haven't actually started that process, and you're interested in this subject. So, and I think we'll close out. And it looks like about 2/3 of you are using this for GIS, and about two-thirds are still thinking about ways you can use this. So we're going to close that poll out. I do want to point out, while you're doing that, we've got a list of resources here. We talked about ArcGIS and Enterprise and story maps and dashboards, and we showed the product on demand, which is part of our ArcGIS production mapping. We talked about imagery. We talked about the ArcGIS Hub. All of those are available as resources, and also as well as our new community place on GeoNet, the National Geospatial Mapping and Charting, which you guys are the first to hear about. We'll be opening up this week. So as we go to our questions, we've got a question regarding the USGS, and the question is, so why did USGS decide to host their product on demand in the cloud? So I just mentioned that briefly. So the USGS wanted to leverage some of the advantages of the cloud, particularly the ability to process large amounts of data in a short amount of time. If you remember, they were processing all of the current data into the 9,000 unique 1 to 24,000 scale maps, and later there were 85 maps of 1 to 250K. That was all generated on the fly from real-time information in their authoritative database, and they automated that with the product on demand, and it required a lot of computer processing. And so USGS used the elastic aspect of the cloud to quickly spin up the capacity when they needed it during the disaster. But once the disaster response had dwindled, USGS simply had to reduce the cloud computing they needed and go back to normal levels. So they didn't have that expense. So they didn't have the expense of ramping up a lot of servers and hardware. And once they were done with it, they just shut that down. We've got another question on the GeoAI, and it's could you explain more about how you used artificial intelligence to do the damage assessment? So where can we get information on ArcGIS and the use in artificial intelligence? Well, let's see. There's a number of things Esri's been showing about the AI, or what we call GeoAI, the application of GIS and artificial intelligence. Recently we did a webinar on GeoAI and national mapping and statistics. We did that last month, and we can make that available as part of the after this webinar to you. We'll make this webinar and that webinar available to you. There's also a lot of materials that are out on the Esri website. I mentioned the map gallery earlier, where you can go see projects. And we've got tools in GitHub. We've got models, we've got training models, we've got the tools that connect to the open source deep learning and machine learning models that are out by a number of different organizations. We work with any of those open source type AI models, and we put those together with ArcGIS, and we make those available in GitHub. So it's really an easy one-stop shop to get everything you need for applying your GIS to AI, and it eliminates a lot of the setup time, and there's a lot of tools there to enable you. I also want to point out we've got a GeoAI webinar coming up on national government on the 14th of October, and we'll be looking at some of those applications. So that's a quick kind of where you can find AI. Yeah, Steve, go ahead.
Yes. So another reminder is the Esri International User Conference. The team here will be available at the National Mapping and Charting, as well, and Official Statistics Showcase there. So if you're attending the Esri User Conference, which is virtual this year, we'll be able to meet on more detailed technical questions as well.
Okay, great. Yeah, good point, Steve. Thank you very much there. And with that, we're coming to a close on our time. If there's any other questions, I think we answered the questions that we got in. I'd like to thank you all for your time. And again, we'll have resources in the webinar afterward. We would like to invite you to take a survey. It takes 1 minute. And we've just got a series of questions there that are very easy, just to click some buttons. And we'd love to have your feedback. And with that, we do thank you for your time here at Esri. And we look forward to engaging with you more in the future.